Hello friends, in this session we shall discuss various examples. Here we have given the examples for number sequences. In this first sequence I am starting with 4 because in every number sequence we should know the starting number and we should also know which number we are repeatedly adding. So here we are starting with 4 and I am repeatedly adding number 4. So 4 plus 4 equal to 8, 8 plus 4 equal to 12, then it goes on like that. So this number sequence, it also represents the multiplication table for the number 4. Here I have the next number sequence that starts with 5 and I am repeatedly adding 3. So 5 plus 3 equal to 8, 8 plus 3 equal to 11, 11 plus 3 equal to 14, it goes on like that. Here this number sequence does not represent any multiplication table. This represents multiplication table 4, but this does not represent any multiplication table. And this is very wonderful sequence here, Fibonacci sequence. Here we have two starting numbers, 0 and 1. Then we generate the next number by adding these two numbers. So 0 plus 1 equal to 1. Then we generate this 2 by adding the previous two numbers. Okay, we generate a number by adding the previous two numbers. That is the principle we follow to generate the whole Fibonacci sequence. And all these sequences are infinite sequences. They just go on like that. Here this is another beautiful sequence. This represents the multiplication table for number 9. 9 2s are 18, 9 3s are 27. Here you take any number, you add the two digits, you get 9. Here 9 7s are 63. 6 plus 3 equal to 9. We have square numbers. A square number is formed by multiplying a number with itself. Okay, here 16 is a square number and it is formed by multiplying 4 with itself. And this 4 into 4 is also represented as 4 to the power of 2. 4 raised to 2. And 5 raised to 2 is equivalent to 5 into 5. That is 25. So these are all square numbers. 16, 25, 36 and 49 are square numbers. So they can be represented as a square of dots or stars. Here I am representing number 16 with 4 rows and 4 columns. Composite numbers, these are the examples of composite numbers. They are composed of smaller numbers. You take 12. 12 is composed of 2 and 6 or 3 and 4. 2 into 6, 3 into 4 is 12. Similarly take 8. 8 is 2 into 4 or 4 into 2. What about 15? 3 into 5. What about 14? 2 into 7. 10, it is 2 into 5. 9, it is 3 into 3. Composite numbers means the number is composed of smaller numbers. Then we have the most wonderful prime numbers. So these are the various examples for prime numbers. A prime number is divisible by 1 and itself. No other number can divide a prime number with remainder 0. So here 5 is a prime number. It is 1 into 5. You cannot find any other factor. Apart from 1 and 5, you cannot find other factor. 13 is a prime number. Can we arrange a prime number as a square or as a rectangle of dots? No, we cannot. Always one star will be left out. Take for example 13. I have 3 rows here and 4 columns. We only get 12. What about the other one? We cannot form a rectangle here. So here and here I try to represent number 7 and here also I cannot form a rectangle. In this slide I have given various examples for exponents. Exponent means a repeated multiplication. Here I am multiplying 2 with itself. That is 2 square. Exponent is 2, base is 2. 2 cube or 2 to the power of 3 is 2 multiplied with itself 2 times. 2 to the power of 4, 2 multiplied with itself 3 times. 2 to the power of 4 means 2 is repeated 4 times. 2 to the power of 3 means 2 is repeated 3 times. And the operation is performed 2 times. Okay. In all these 3 operations, 2 is the common base, whereas the exponents are different. Here it is 2, here it is 3, here it is 4. Similarly, in all these operations, the base is the same. It is 3. 3 square means 3 into 3. 3 cube means 3 is repeated 3 times, but multiplication is performed twice, 2 times. 3 to the power of 4, you have 4 3's and 3 multiplication operations. You will get 81. Thank you very much. We shall stop here.